Let's do a little bit of basic trig review here. So we're going to start off just by solving a couple of these basic trig functions before we start getting into the word problems or the rigging assignments or any of the more complicated stuff, let alone the AC theory, and just look at the basic right triangles that we're going to solve for with some of the missing values. So we'll start off with the 30-inch hypotenuse here. So if you're looking at this triangle on the right, we have a 30-inch hypotenuse value and a 25-degree angle, and those are our two knowns. And what they're asking us to solve for is theta, the missing angle, the adjacent side of the 25 degrees, and the opposite side, which is B and A respectively. So before we start, and to help those that are still trying to memorize some of it, let's just write down some of the things that we need to start remembering and that we're going to be using here in solving this one. So we have our SOHCAHTOA, and a little bit of something called Pythagorean theorem, which is our a squared plus b squared equals c squared. So that's the two things we're going to be using most frequently with a lot of these, aside from our 180-degree rule right triangles. So to start off, we're going to look at solving for, let's say, A. So we're solving for A from the perspective of the 25 degrees down here. We're going to be looking at the opposite, which is A over the hypotenuse. So opposite over hypotenuse, I know that's sine, right? So the sine of 25 degrees equals the opposite, which I know is A, over the hypotenuse, which I know is 30. So this is similar to some of the basic algebra that we were doing some of the other practice problems that we'll have. And we're really just trying to solve for this variable here, A. So it's the only unknown value. And as long as we isolate it on one side of the equal sign by itself, we should be able to solve for that. So the first step in doing that would be to take this side and multiply it by 30, which 30 over 1 is the same thing as 30. So I have a 30 on the bottom, a 30 on top, which cancel out, but I have to do the same thing to the other side, right? So anything over 1 is itself. So after I cancel those out, I'm left with 30 times sine 25 equals A, my unknown side. So if you punch that in your calculator, 30 sine 25, that would leave you with A equals 12.679. And our units are inches. So A, we have 12.679 inches. So let's make a little room here and let's make this easy on ourselves. We don't need to do our SOHCAHTOA every single time because we have some other values that make it a little easier to solve for that. So the other two missing values, I don't have to use SOHCAHTOA at all. I can use the Pythagorean theorem and then our 180 total triangle degree rule. So if I'm solving for the missing b, I know that a squared plus b squared equals c squared, and c would always be the hypotenuse. So I know that a, which is 12.679 squared plus b squared equals 30 squared. So let's see what that looks like. So 12.679 squared, that's going to give us 160.757. Now again, any of you guys who are more familiar with your calculators and comfortable with it, you can plug all this in one equation rather than moving it around like we're going to do, but this is just to brush up on our practice. So 30 squared, it's going to give me 900. Now again, I got to get this b by itself. So if I have 900, and I'm going to subtract my 160.757, Let the calculator do all the work. And that leaves me with b squared equals 739.243. Now I still got to get the b by itself, and I have this squared with it. So the only way to get rid of the squared is to take the square root. So the square root is going to cancel out the square, and that'll leave me with b equals the square root of 739.243. Again, we'll have the calculator do that calculation for us. And that gives me b equals 27.189. So the only value I'm missing still is that missing angle. And while I could use some inverse trig in two of the sides of my choice to solve for that missing value, I can also just take my 180-degree rule and say that if I have 180 degrees in a triangle and I subtract my right angle and my known angle, the only amount left should be the missing angle, which here is theta. So 180 minus 90 minus 25 leaves us with 65 degrees, which is how we have our 65 degrees. And that probably the easiest method, even though it looked a little bit drawn out. We wrote down every single step the whole way, so it looks a little bit harder than it was. But we found all the missing information here using each of the different trigonometry methods that we'll be using here, except for the inverse trig, which we'll do a couple of those later too. So I'll post a couple more of these for review, and then at that point a lot of the stuff should just be second nature. We're going to be building on these concepts very quickly, so I want to make sure that you guys can solve these and you're not hesitating or struggling to understand why you're using any of these methods or numbers, especially when we start getting into the AC parts of it. All right, we'll check back in soon.